Hi gang, let's continue on with our chain rule. Now we're going to do the power rule combined with the chain rule. So it says here, if n is a real number, n is our exponent that we have here. If n is a real number and u is equal to g of x is differentiable, then u equals g of x. The derivative would look like this. The derivative of u to the n power, we would take the power and move it out front and subtract by 1. So that guy comes to the front. And then we take the derivative of the inside. So notice we have our power there. The power moves to the front and we subtract by 1. And then we take the derivative of the inside, and that's this part right here. Remember that our inside function stays the same when we just do the power rule. An alternative notation would be this guy down here. So again, we have our outside function is going to go to the outside, or is going to go in front here, and we subtract by 1. And then we take the derivative of the inside function, and that's this g prime here, where g of x, that's my inside function, that's the part that stays the same. We do the power rule, subtract by 1, keep the inside the same, and then take the derivative of the inside. Okay, so I have a couple problems. Flip over to page 2 and let's try these guys. So when I look at these, I first notice that my outside function is the 100 and my inside function is the x cubed minus 1. Remember that the derivative of something to the 100th power is 100x to the 99. And the derivative of my inside function would be 3x squared minus 0, and we throw out the 0. So we're going to do these in 2 different layers. We start and we say that y prime is equal to 100 x cubed minus 1 to the 99. Remember, my inside function stays the same right there. And then I multiply it times the derivative of the inside, which is 3x squared minus 0. Remember, we throw that out. In this case, we would probably combine my 100 and my 3. And we would say that the derivative of this is equal to 300x squared times x cubed minus 1 to the 99th power. All right, let's try it again. Looking at example 5. Again, my outside function, the part on the most outside, is the root, and then on the inside I have the x squared plus 1. When we do this, I think that it would be nice to see this as a power. So we should think of this as x squared plus 1 to the 1/2 power. And again, my outside function is the 1/2, and my inside function is the x squared plus 1. When we take the derivative of each, the derivative of a 1/2 power would be 1/2 x to the negative 1/2, this being my inside function, and when I take the derivative of x squared, that's going to just be 2x. So the derivative of this function is going to be first my power rule, 1/2 x squared plus 1 to the negative 1/2. This guy stays the same, just did the power. And then the derivative of the inside is the 2x. If we were to write this without, just cleaning it up a little bit here, the 2 and the 1/2 would cancel. This negative exponent would move to my denominator, and I would have x on the top and the square root of x squared plus 1 in the bottom. Remember, the square root comes from that negative 1/2 power. All right, number 6, let's try this one. And again, before we start this, I would clean this up. If this is in the denominator, I would move it to the numerator by changing the negative of the exponent. And then this cube root, I would write it as a power. So I would think of this function, first of all, as x squared plus x plus 1 to the negative 1/3 power. And then I remember that I have my exponent as my outside function and the parentheses as the inside function. Let's try to go right into our derivative. F prime of x is equal to first the power, negative 1/3 x squared plus x plus 1 to the negative 4/3 power. Remember, negative 1/3 minus 1 is negative 4/3. This guy stayed the same, but now we have to take the derivative of that. The derivative of the inside is 2x plus 1. And then if you want to clean this up a little bit, the 2x plus 1 is in the numerator. The negative is in the numerator. The 3 is in the denominator. And the x squared plus x plus 1 to the 4/3 is also in the denominator because of the negative exponent. And that probably would be about the best we can do. That is the derivative using the chain rule. Let's try these last two problems here in this video. We have a quotient rule and we have a product rule. In the quotient rule, we have an outside function that is the 9, and we have the inside quotient rule as the inside function. So when I do this, g prime of t, first would be my my power rule, 9, and then t minus 2 over 2t plus 1 to the 8th. This guy right here stays exactly the same, and I just did the power rule. Then I multiply it times the derivative of the inside. And so remember, we have to do a quotient rule on this. So that would be low 2t plus 1. D high is a 1, less high t minus 2. D low is just a 2, all over 2t plus 1 quantity squared. If there was anything that we could do to make this a little bit better, it would be to do some distributing here. And I would get 2t plus 1. And then I have a minus and a little more distributing. That would make minus 2t. And then plus 4, because we have two negatives there. My 2t's would cancel out because they're one positive, one negative. My 1 and my 4 would add together. And I would end up with 9 t minus 2 over 2t plus 1 to the 8th times 4 plus 1, 5 over 2t plus 1 squared. And that would be a great place to stop. We could do a little bit more simplifying. It is 9 over 1, so those can multiply together. We have 45, and then I have 8 2t minus 2's. And then I have 8 and 2 more of them, 2t plus 1 to the 10th. If you wanted to get really crazy on your simplifying, you could go right to there. All right. The last one that we have over here is a product rule because of this multiplication right in the middle. So we will have to do a product rule and a chain rule when we look at these. On the first one, remember we have the 5, and then my inside function is 2x plus 1. On the second one, we have the 4, and my inside function is x cubed minus x plus 1. So we have to combine things here. So this is my first function, and this is going to be my second function when I talk about 1 and d2. Those are the ones we're talking about. So we have our first function, 2x plus 1 to the 5th, times the derivative of the second function, which means the 4 comes out front, x cubed minus x plus 1 to the 3rd. Remember, this guy here stays the same, and then I have to multiply it times the derivative of the inside, which is 3x squared minus 1. And then I have to add the second times the derivative of the first. The second is x cubed minus x plus 1 to the 4th times the derivative of the first, which would be the 5 out front, 2x plus 1 to the 4th. Remember again, 2x plus 1 didn't take the derivative, just the power rule, times the derivative of the inside, which is just a 2. And then if I can simplify, I would do that. On this one, you can't simplify anything that has a power more than 1 because you would have to multiply those together. But this 4 could distribute into that 3x squared minus 1. On this one, on the second part, we have the 4th power, so we can't do anything with that. And we have this one with the 4th power, but we could multiply the 5 times the 2. So I would think if you wanted to go really wild and crazy, you would have 12x squared minus 4, distributing on the top, times 2x plus 1 to the 5th, times x cubed minus x plus 1 to the 3rd, plus, that's this plus right here, 5 times 2 is 10, and then x cubed minus x plus 1 to the 4th, and 2x plus 1 to the 4th. And I think that would be about the best you could do. There's a little bit, oops, I forgot parentheses here. There's a little bit of greatest common factor that you can do, but I think that's probably as much as we need to do. All right, so that is power rule combined with chain rule. In the next video, I will do the last 3 questions there. Make sure you get a hold of me if you have any doubts.